Okay, so how is it going, everyone? So what we're going to do today is we are going to get started with our question for today. Today we're going to be talking about a bit about space. So what I want to do is I want you to, well, you guys join the Zoom, yo, what up? What is up, fam? What is up? So what I want you guys to do is I want you guys to tell me, when do you expect the first humans to travel to Mars? There is no correct answer here, because if I knew the correct answer, well, I'd be a very smart person. So I want you to decide. You can decide. You can say, I think we're going to travel to Mars by 2030. I think we're going to travel by 2050. I think we're going to travel by 2070. And I think we're going to travel by 2100. Any of these are viable answers here, but I do want to see what we can think. Once again, there's no correct answer here, so I do want to try to see if we can get everyone to respond. I think we're at 21 out of 24 right now. 2050, you think 2050?
Yeah. Like, how we're so behind, we're not good at 10 years.
I mean, we went to the moon in 10 years from 1960.
A whole different volume.
That is interesting. We'll take a look at it today. We'll see how feasible it is. But I do like hearing that. I think so far. I think so. It seems that we have a spread. I'm gonna take another minute or two for people to answer. But as of right now, it seems that most people have decided that around half of the people have decided that 2050 is realistic. About a quarter says 2030, and then about a quarter says 2070, and then we have maybe a couple of people who think 2100. So the correct answer is, there's no correct answer because I said there's no correct answer. So we will see. We will see eventually at the end of today what you guys think after we learn about some stuff about rocket science. But as a continuation of this question, what I want you guys to also think of is, when do you think we will travel beyond our solar system? So when do we think is a realistic timeline for us to travel to the nearest star system other than our own? So we're talking past Pluto, we're talking past, your Neptune and stuff. We're talking very, very, very far away. So beyond our solar system. So when do we think is a realistic timeline for you to travel to the closest solar? Did you say something? It's okay. Mine makes a fan noise too. If you make Star Wars a reality, I'll give you an A in the class.
My physics skills are really good. Bringing next rocket scientists over here.
I won't be surprised. I won't be surprised. Would. Okay, so we have about 19 out of 27 have responded. So for those of you just joining us, take a look at this question here. What do you think is a realistic timeline for the first human to travel to the closest solar system other than our own? We have about 19 out of 27 so far. Take another minute or two for people to answer.
You might give our Alex in here. Yeah. What really the walk? Sit down. Why don't you sit down and walk? Yeah.
So I'm looking at the poll right now. It seems like a third of our class says by 2200. About a third says never. About a sixth, so about 4 people say by 2100, and about 6 say by 2050. I'm very interested in seeing what you all think. So we'll have to take a look at why, or what are some of the things that are challenges that are facing us in our attempts to explore space. So what we're going to be talking about today is, why is it so hard to explore space? So in the 1970s, NASA had a plan to send humans to Mars. And if you ask anyone who was alive in the 1960s, which is obviously me, I was obviously alive in 1960. What we'll say, as I'm a millennial, so much older than all of you. So they would have said that they expected to send humans to Mars by 2000. So they would have said by the 21st century, we would definitely have humans on Mars. However, we're 50 years later from 1970, and we still haven't really sent any humans to Mars. In fact, we haven't even really gone that close. We haven't even attempted yet. So what I want you to do is I'm going to put you in your groups, and I want you to discuss some of the obstacles that may have prevented a human mission to Mars. And I want you to come up with a list of at least 3 major challenges that NASA has to overcome. Oh, I totally forgot there's a graphic organizer that goes along with this today. Help you figure it out. So I'm going to link it right now. So that's the graphic organizer. The first one's the graphic organizer. The second one's the slides. So fill out your graphic organizer because that'll help you organize your stuff. And what I want you to do is I want you to come up with a list of 3 major challenges that NASA has to overcome in order to send people to Mars. So I'm going to put you in your groups now, and when I bring you guys back, so let's take, I don't know, 5, 10 minutes or so, and I want you to come up with at least 3 major challenges that NASA has to overcome in order to send people to Mars. So I'm going to open it now.
You never changed the breakout room.
So what we're gonna do, what we're gonna do now is we're going to try to go around and, am I echoing? It's okay. It's okay. I'm just okay. So we're gonna try to go around and try to discuss some of the ideas that we came up with. So what I'm gonna want you to do is we're gonna give you a couple of minutes in the chat here. What I want you to do is I want you to write out at least one challenge that you're, so each person should at least share one challenge that you or your group came up with. And it'll take about 2 minutes or so. And then around 12:22, 12:23, I'm gonna tell you to hit enter. And then we'll see what some of the challenges that you or your group have come up with in terms of the things that NASA has to overcome. What are some of the challenges that NASA has to overcome? So take 2 minutes, put it in the chat, whatever ideas your group came up with to let's take about 30 seconds or so, maybe a minute or so. And then what I want you to do is I want you to have your answer ready. And then we'll take a look at what people have to say. Take one more minute. We have some good ideas so far. It's actually a good idea. No, that's actually a really good idea. Yeah, so one of the reasons why we want to establish something on the moon is because it's much easier to launch things from the moon than it is from Earth. Um, you do use
I
a
think
lot
it's
less fuel.
because it's easier to launch things from the moon because the atmosphere on the moon is not that big.
Exactly. Yeah.
Also, the gravity on the moon isn't that good. Hugh?
Yes, the gravity on the moon is a lot smaller than the Earth, so it definitely is a huge. Okay, by the way, so whenever you're ready, hit enter. I want to see what everyone has to say. The gravity. So, what we had a couple ideas. One of the ideas that Hank came up with was that you could try to launch things from the moon because the moon has a lot less gravity than Earth, and it doesn't have as an atmosphere. So one of the ideas that NASA want to do, they want to build something on the moon and then launch things from the moon. That's a good idea. What other ideas have people come up with? Okay, I'm gonna go start reading through some of the ideas we have. So one idea that came up was having enough funding. So NASA's budget used to be the 1960s when we were in the space race. NASA's budget was about 10% of the U.S. budget. Nowadays, it's about 0.3%. So it's quite a bit smaller. Another challenge that people have is having enough oxygen for the whole trip. Is definitely a huge thing. Actually, what's more challenging about oxygen actually is reducing how much carbon dioxide you have. So I don't know if you've ever watched the movie Apollo 13, um, but Apollo 13 was well, it was in 1960 something. It was the third mission to the moon, and one of the issues they had, well, the rocket essentially had an issue. But one of the main time constraints was that you had to filter out the carbon dioxide because if you couldn't filter it out fast enough, you would if you couldn't filter it out enough, you would die essentially. And that was actually more of a concern than oxygen. But oxygen is definitely a huge impact, a huge factor. Um, People would oppose funding space travel during a pandemic. Yep, yep, that's definitely an issue. Changing atmosphere. So yes, Mars doesn't have an atmosphere, and Mars's atmosphere is really weird. It's very thin.
It's very thin. And this actually poses quite a bit of issue, and we'll take a look at it maybe later today. Mars has no water. It could be easy to run out of resources. Yeah, it doesn't really have much. Time is a challenge because of fuel. Yeah, you need to have the fuel to travel the distance. Um, yeah, so those are all some really good challenges of going to Mars. So what we're going to do is we're going to look at some of them in more in depth today. Um, and so the first one we're going to take a look at is, well, the first challenge we're going to have is that Mars is really, 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 really far away. So what I want you to do is I want you to go on Google, and I want you to Google how far Mars is from Earth, and I want you to record a distance in your graphic organizer. So go on Google, search up a distance, how far Mars is from Earth, and then record it in your graphic organizer. So when you go on Google and you type in how far is Mars away from Earth, Google will give you a big fat number. Do not just write the number down, because it's actually a lot more complicated than that. So what I want you to do is I want you to go through maybe a couple of articles on, on the subject. So go through Google, type in how far Mars is from Earth, and I want you to read through a couple of things, and then I want you to see why it's a lot more complicated. Once you do that, then I want you to try to write down a number for how far Mars
Mr.
is from
Hugh,
Earth. hmm
I
Yep.
already kind of know why it's more complicated.
You don't know why it's more. So this is what this is why I want you to do a little bit of research here. So what I want you
No,
to do is
I already know why.
you already know why.
Yeah.
So why do you think it's more complicated? Oh, I'll give you a chance to share it in a second. I want to give people a
Oh,
chance to research it first, but I
okay.
will ask you to share. Thank you for being so proactive, Hank. So give you a couple of minutes, give you a few minutes. So I want you to figure out how far Mars is from Earth. Do a little bit of Google research on this, but however, you will have to read through a couple of articles because you take the big fat number that Google gives you. It's not actually completely accurate. And then I also want you to write down why is the distance from Earth to Mars so complicated? Because it's not just a number. Why is it more complicated than that? So let's take 3 minutes or so. And so we'll take another minute or so for people to figure out. Actually, is that enough time? I don't know. I don't know how long it. But whenever you are ready, what I want you to do is I want you to message in chat what distance you found and why it's so complicated. Uh,
Okay.
So Hank, you ready to share? Would you care to share for us why?
Okay,
What you know? Go ahead.
Well, it's so complicated because its orbit, because it's orbiting around the sun, meaning it could take different times for it from when it's the closest to Earth and then the farthest away from Earth. So I got for the minimum distance at about the minimum distance is 33.9 million miles. Well, about maximum distance is 168.47 million miles.
So what Hank is saying, so I really like what Hank was saying. So what Hank is saying is that, the Earth and Mars are both rotating around the sun. However,
Yeah.
they're not like rotating at this perfect same speed, right? So what
Yeah.
happens is that sometimes the Earth and the sun can be really close to each other, and sometimes the Earth and the Mars can be on opposite sides of the sun. And so there is a minimum distance, and then there is a maximum distance of the two. So if you went on Google and you just typed in distance from Earth to Mars, I think that actually gives you the average distance, but it doesn't really tell you the full story. The full story is that there is a minimum distance and then there is a maximum distance of how many miles. So for now, what we're going to use, we're just going to use the Google number here. The Google number is this one, the second one that Hank wrote, 168.47 million miles. We're just going to use that because that's the distance that Google gave us. But it is more complicated than that because there isn't just one fixed distance from Earth to Mars. Both are orbiting around the sun. And so what it means is that sometimes it's going to be very close to each other and sometimes they're going to be very far away from each other. Those are some ideas as to why it's so complicated. So what we're going to do now is using the distance we found, the one we just wrote down, 168.47 million miles. What I want you to do is I want you to determine how long it takes for a rocket to travel from Earth to Mars. So right now, the rocket that NASA is using that NASA is designing is it's called SLS, the Space Launch System, and that is, oops, so that's called the Space Launch System, and that travels at the speed of 24,500 miles an hour. So what I want you to do is I want you to figure out how long does it take for a rocket to travel from Earth to Mars. So the distance between the two is 168.47 million miles. And then the speed that the rocket can travel at is 24,500 miles per hour. So figure out how long it takes to travel from Earth to Mars.
How do I calculate this? Do I just type it in?
So how do you think you would calculate it? So what we have is we know how far they are from each other, and we know how fast the rocket travels per mile.
Wait,
per
how
hour.
fast is it? I didn't know about it.
Yeah, so it's on the screen right now, right? The rocket is traveling at 24,500 miles an hour, and the sun and Earth, the Earth and Mars are 168.47 million miles away from each other.
Wait, can you repeat that? What's the rocket again?
The rocket is traveling at 24,500 miles an hour. So it's on the screen right now, Hank. It's also on your graphic organizer as well.
I don't see it on the screen.
Why? Oh gosh, it's not. Okay, thank you for that. That would have been. Oh gosh, that actually explains a lot. Actually, hold on, let me fix that. Okay, here we go. So so using the distance from Earth to Mars, the one we found earlier, I want you to figure out how long it takes to go from a rocket to go from Earth to Mars. And yeah, be very careful with units because they can be very complicated otherwise. What I also want you to note down is that in this particular model, what we are assuming is that Earth and Mars are both stationary, Then the rocket just goes from Earth to Mars in like one straight go. So once you figure out how long it takes from the rocket to go from Earth to Mars, I want you to try to discuss the limitations and drawbacks of using this stationary model. What does this model not account for? So we're modeling the Earth and Mars as just both two stationary objects. And the rocket is just flying from Earth to Mars. We're just trying to figure out how long it takes. But there's limitations for using this model, which I also want you to discuss. So I'm going to just put you in your groups again, and then I want you to, when we come back, I want you to have figure out a time it takes to go from the rocket to go from Earth to Mars, and then think about what are the limitations of using this theory model. What? That's Oh, awkward. I was muted. Okay, go ahead. Okay, so very awkward. I know. Tell me something I don't know. Um, okay, so if it's 168 million miles, we take our distance and we divide it by our speed. What we get is that our time is roughly 6,800 something hours, something like that. So we took our distance, which was 168 million miles, we divided by 24,500 miles per hour, and we get our time is roughly 6,800 hours. Now, this in itself isn't very helpful for us because I don't like it's kind of hard to visualize this. So what I'm doing is I'm going to convert this to days, and this is roughly like what was it, 200 and something was like 280 days or something.
Check. Let me check.
So
Let me check. I'll check. I'll check.
So
yeah,
to-
thank you, Hank.
It's 286.51.
286. Thank you very much. So this is going to take 286 days to go from Earth to Mars. And so how long is 286 days? Well, that's roughly about 9 to 10 months. So it's going to take about 3/4 of a year to go from Earth to Mars using the Space Launch System. So now the thing is about this model is that we're assuming that the Earth and Mars are both stationary. We're going from point A to Earth to Mars. And we're going this in one go, A to B. However, there's some issues of this stationary model. So what is this model not accounting for? So I know for a lot of people have told me is that first off, the one thing that we're not considering is that the Earth and Mars are all rotating around the sun. So however far they are now may not be how far they are in a month, how far they are in 2 months. So that's constantly changing. So just saying that they may be 168 million miles an hour far away now, but in a month or in a day, that could change, right? So it's not accounting for that change in distance. It's also not accounting for the fact that Earth and Mars are also rotating on themselves. So depending on where we start, depending on where we land, that can also change how far the distance is. Another thing that could potentially change it is like if we run into asteroids, right? We might want to change the path we take. And so this is just assuming that we're just going from a straight line from Earth to Mars, when in reality the path itself is much more complicated because we're dealing with rotations, we're dealing with both planets revolving around the sun, we're dealing with stuff like that. So the actual path itself is a lot more complicated. So this stationary model is very flawed and just sort of assumes that we're going from point A to point B. It's not really accounting for a lot of the other factors involved. However, even though the fact that this model is not very accurate, we did learn a lot from this because we even though it's not accurate, we do have a rough time frame for roughly how long we can expect it to take. And we can expect it to take at least several months, even close to a year. That's still a very realistic time frame. And from this model, we know is that we can use this information to try to make further deductions from this. So what one group told me sort of realized is that if it's going to take 9 to 10 months to travel from Earth to Mars, oxygen is going to be a huge issue. How are you going to have enough oxygen for 9 to 10 months? So that's a really good analysis that we made just from looking at this model. So there's some other things that this model can tell us, right? 286 days. Like what if we can run out of water? So there are a lot of other issues that we can make. So just from this model, we can also make further deductions based on the information that we got. So this is something we call modeling, where it's just not this. It's not quite Victoria's Secret modeling, but we're talking more of like science modeling. And this science modeling is it's basically like you're creating like theories or we're creating like systems that sort of showcase the different factors in play here. So what we're going to do now is we're going to look at another particular we're going to look at another particular idea here, which is making things go really fast. So because Earth and Mars are very far away and it's going to take us roughly 9 to 10 months, we want to make things go as fast as we can, right? So we want to make things go if it, the rocket is moving at 24,500 miles an hour, which is really fast. But even at that speed, it's still going to take us roughly 9 to 10 months. So what I want you to do is I want you to think about, do you think it's harder to accelerate from 0 to 50? Or do you think it's harder for something to accelerate from 50 to 100? Or do you think it's the same? And why do you think so? So I'm going to give you a few minutes or so, and I want you to think about, is it harder for something to accelerate from 0 to 50? Or is it harder for something to accelerate from 50 to 100? Or do you think that it's the same? So I'm going to put you in your groups now, and Okay, so it's 1:09 now, so we're gonna wrap up here. So we're gonna continue talking about rockets and stuff on Thursday. I think the one thing that I wanted to sort of recap was, is it harder to go from 0 to 50, or is it harder to go from 50 to 100? What I want you to think about is if you're in a car, right? When you're starting to go very fast and you're hitting the gas pedal, you're really not starting to speed up a whole lot. Like if I'm on the freeway and I'm trying to go from 60 to 70, it takes quite a bit of time. Whereas if I'm going from 0 to 10, it really does not take a lot of time. So it's definitely a lot easier to go from 0 to 50 than it is from 50 to 100. So that's just one thing I want you to take away before we continue with this on Thursday. Other than that, you don't have any homework, and then I'll see you guys on Thursday.
Okay, bye, Mr. Hugh.
Thanks, Mr.
Bye.
Hill.
You saw Mr. Who? Later, Mr. Who.
See you, George. See you, Miguel.
Later.